We're going to look at something called percent yield. This is an indicator of efficiency, and so this is really important in industry where you're trying to make a product. Like if your product was ammonia and you're making ammonia, then you want to know, well, how well am I doing? Am I getting all of it that I should be getting? Is it even possible to have 100% efficiency? To understand percent yield, we have to understand the theoretical yield and the actual yield. The theoretical yield is the maximum amount that could be made. So if everything went perfectly, what's the maximum you could make? That's what we've learned how to calculate. If everything went really well, how much product could we make? That's theoretical. It's in theory. The actual yield is the amount you actually make. You can't really calculate that in this class anyway.
How can they name those something so simple?
Why did they name those things so simple? Okay, but there's lots of things.
Stoichiometric reaction.
Stoichiometry. That's Greek.
A completely used reaction.
Yeah, I can't answer. There are a lot of things, though, that are named fairly obviously. And so let's just, embrace those and be thankful when they come up. But you're right, theoretical yield, actual yield, they mean what you would think that they mean. The actual yield is how much you actually get. Now, usually, the actual yield is less than the theoretical yield, usually. And so percent yield is defined as the actual yield divided by the theoretical yield times 100%. So if your actual yield was the same as your theoretical yield, you'd have 100% efficiency. You'd get 100%. Why could there be less than 100%? Let's think about the sandwiches. You're making sandwiches, and what if you drop one on the floor? Can you serve that? No, you really shouldn't. 3-second rule, right? Okay, but you can't sell that one. If you're working at Subway and you drop it on the floor, that one gets thrown out, right? So that's one less sandwich. Okay, so then your yield, your percent yield goes down. Or, you're at home and you got distracted by the phone, you turn around and the cat is eating some of the meat, right? Or you got really, really tired and you just didn't finish. There's all kinds of reasons. How could the percent yield be higher than 100%? That doesn't seem real possible, does it?
If you got more than your
Yeah, you would get more than your theoretical yield. Could you actually make more sandwiches than you theoretically could make?
Yeah, you find another loaf of bread.
You find another loaf of bread. Okay, so that doesn't work out so well with the cooking analogy. It just doesn't. But let's think about chemistry. And so we're making a product, and we isolated it from a solution, and we're drying it, but we were in a hurry, and we didn't dry it completely, and it's still wet. Then when we weigh the product, it's heavier than it actually is because it's also got the mass of water in there. So that could cause your actual yield to be higher than your theoretical yield. Or the crazy thing that happened in my quant lab in college, we were burning things in crucibles, and a fly flew past and fell into the crucible and got burned up. I mean, how random and unpredictable is that? Well, now he's got a fly in his sample, right? So that's going to make the sample weigh more.
Then he should capture the fly and weigh that.
Yeah, this is what he actually did. He went around the building and he caught 10 flies, because some are much bigger than others. He caught 10 flies and he ashed them in a crucible and determined the average mass of an ashed fly and subtracted it from the mass of his product. He honestly did that. It was fabulous. I don't remember. You remember these weird snippets from your past, and that one is just... That made a big impression on me because that was just so awesome. It was a very long, I think it was like a 6-hour, 2 lab periods we'd been working on this, and we were graded on our result, just the number, your percent yield. And so if it was in this range, you got an A, and if it was going to be 105%, you would not get an A, and we were all wanting to get it. You could write that down, but the person grading it wouldn't take that into account, because, you screwed up. You didn't defend your crucible from flies. Anyway.
Product plus actual fly.
Yeah, but anyway, but that's an example of how you could get a theoretical yield that's greater. You didn't actually produce more products. Something else got in there. So some sort of a contamination could give you a higher yield. So if you see on a test question or in an example a percent yield that's higher than 100%, don't freak out. But most of the time it should be less. So how do we calculate these? Well, we're going to continue this example. It's not the last example, but it's the one before with the A and the B. So we already did that calculation and figured out that in theory, we should get 8.33 grams of C produced. Now they're saying that 7.23 grams of C is what was actually made in the lab. What's the percent yield? The theoretical yield is something that you can calculate using that process we just learned. The actual yield is either something that you measure in lab when we're doing an experiment, or they have to give it to you, because there's just no other way. And so that can help you to identify which is theoretical and which is actual. So the percent yield is the actual over the theoretical times 100%. So the actual yield, they tell us, is 7.23 grams. The theoretical yield we calculated earlier was 8.33 grams times 100%. 'Tis the season for sneezing. What happens to the units there? They cancel out. Grams over grams. They go away. And so what unit do we end up with? We end up with percent. So anytime you calculate a percent anything, the unit should be percent, not grams per cubic centimeter or anything other crazy thing. I see the funniest things on the lab reports. 7.23 divided by 8.33 times 100. And we have 3 sig figs. We should end up with 3 sig figs, 86.8%. That's the percent yield. So a number like that can be used to predict, if your industrial process has an 86.8% efficiency rate or a percent yield, then you can use that to anticipate, okay, if I want 100 grams of this, I'm going to actually have to start out with more because I'm not going to get 100%. You can do calculations like that. We're not going to do them. So let's do one from the very beginning. Find the percent yield of product if 1.50 grams of SO3 is produced from 1.0 grams of O2 and excess sulfur via this reaction. 2S plus 3O2 yields 2SO3. Well, let's take the information and write it under the equation. So 1.50 grams of SO3, 1.50 grams, and 1.00 grams of oxygen and extra sulfur. Part of the challenge for beginning chemistry students is figuring out what am I supposed to do with all these words and numbers, right? So that's what I'm trying to teach you by talking this out as we go along. So we take the numbers, we write them under the balanced chemical equation so we can see the correlation a little better. It's a little more visual. And so we're like, well, they're giving us 2 masses. Are we supposed to calculate, is this a limiting reactant problem? Well, what's the question? What's the percent yield? Okay. So then let's say, well, we want percent yield. That's the question. So they're not asking us for a mass. Percent yield. Okay, well, what's the equation for percent yield? is actual yield. That's just a pretty lame actual. Reminds me of something Andrew said. His brother, well, two of his brothers are in college. He's 4. And he said to me, maybe when I'm in high school, I'll see James. James is in Kansas, and he misses James. Then he says, actually, the last week of my day is college.
What?
Right. What? It makes the child has his time units mixed up. He thinks that a year is like a day. And so, day, month, year, he just uses them kind of randomly. Actually, he said, the last week of my day is college. Cracks me up. So actual yield, that's where that came from. The actual yield divided by the theoretical yield times 100%. Because we're trying to figure out what we're doing here. And squirrel, we get distracted. I don't know, because we literally do have squirrels out there. I didn't actually see him, I just thought about him for some reason. Actually, maybe something happened to our friend. So we get distracted, and then we come back. We say, okay, what are we doing? Okay, they're asking for the percent yield. In order to find the percent yield, I need the actual yield and the theoretical yield. Okay, Mrs. K said that we calculate the theoretical yield, and the actual yield is given to us. Well, let's look back at this equation. If 1.5 grams of SO3 is produced, well, that's the product, right? That's a yield. Is that theoretical or actual? That's actual. Okay, so this one here, that's the actual yield. You see how we figured that out? That's the actual yield. So here in our equation, we're going to have on the top 1.5, try that again, 1.50 grams is our actual yield divided by a theoretical yield times 100%. Theoretical yield we have to calculate. Well, we've got one number left. It's a mass of oxygen. Could we calculate a mass of SO3 from a mass of oxygen? Sure we could. Of course we can. And we can do that. There we go. And we can recover from that. Okay. There's just this little, if I touch the wrong part of the screen, it does that to me. So what we need to do is we need to take this 1.00 grams of O2 and calculate mass of SO3. Grams to moles to moles to grams. Here it is again. Grams of O2 to moles of O2 to moles of what? SO3 to grams of SO3. And get the units in, grams to moles to moles to grams. We're going to divide by the previous unit, so these cancel out. You see what a nice pattern these things fall into? You'll learn the pattern and you can do all kinds of calculations. Okay, relationship between grams and moles for oxygen. Molar mass of oxygen, O2. 2 times the molar mass of oxygen. 2 times 16, last time I checked, was 32. SO3, well, maybe we should actually calculate that one. SO3, 1 sulfur, 32.07. 3 oxygens, they're each 16. It's really a good idea to write that down. If I'm writing it down, you should probably write it down when you do problems. I get 80.07. That's grams of SO3. Anybody else get that? Cough, cough, sniffle. 80.07, that's a decimal point. So those are our molar masses at the beginning and the end. kind of like bookends. And then in the middle, we've got oxygen has a 3 in front of it, and sulfur, I kind of obliterated that. Let's cross it out even more. There we go. Now we can see it. Sulfur has a 2 in front of it. So we take 1 gram, divide by 32, multiply by 2, divide by 3, multiply by 80.07 equals, yeah, that's okay. I come up with 1.67 grams of SO3. Anybody else get that?
Yeah.
Okay, thank you. And then we're like, oh, good, we calculated something. Oh, is that the answer? No, we're not done yet, okay? We have to remember where we were going. And if you get distracted in your problems, write some little notes, like Dora, okay? First I need to identify the actual yield. Then I need to calculate the theoretical yield. Then I need to put it in the equation. And then you go back and look at that. Oh, yeah, that's what I was doing. Because the individual steps are not that hard, but remembering how to put it all together, I understand how that can be challenging for you guys. So, I kind of didn't leave myself much space there, but now we've got 1.5, the actual yield, divided by 1.67, and we multiply by 100, and we get 89.8%. And it's all kind of scribbly and messy, so I'm going to put a box around it so that you can see. There's the answer. That's the end result. Any questions? Aren't those fun? It's even more fun if you throw a limiting reaction in there along with the percent yield. But I won't do that to you, at least not on an exam.
But that would just be finding 2 separate numbers, right? They don't have
Right.
to be everything together.
Yeah.
The limiting reactant kind of turned into percent yield.
Well, it was, I went the wrong way, that's what's wrong. It was a limiting reactant, but we didn't have to figure that out.
If we hadn't been given the 1 gram,
Then we'd have to figure it out.
if we hadn't been given the 1.4 grams of O2, then
If we hadn't been given excess sulfur, if we had been given a mass of sulfur, then we would have had to figure it out.